Hi, we are now going to explore a bit of how our C program is able to represent and display numbers both in the positive and negative systems. I'm first going to create a character variable called num, and I'm going to give it an initial value of 125. Okay, so first we will go ahead to print out the value and its representation in both decimal. Okay, so decimal I will use %d followed by hexadecimal, which is represented using the format specifier %x. Okay, so print out num and num, and we do a \n over here. So \n is new line, \t is a tab. Okay, so let me go ahead to compile and run this first, and let's see what we get. Okay, so value at decimal is 125, hexadecimal is 7D, and you can use your calculator to check it. Okay, so if you key in decimal 125 in your calculator and you select hexadecimal, it will convert to 7D. In binary is 01111101. Okay, what I want to demonstrate next is what happens when you have a continuous counting of this from 1 to 5, and then you sort of flip over, okay, where the most significant bit becomes 1. You can see here right now that the most significant bit is still 0, okay, but after a few, this 1 to 5, so after I hit 1 to 7, when I hit 1 to 8 in terms of decimal, okay, let me just key in over here. So you can see that if I hit 1 to 8, my most significant bit flips over to become 1. So how is that represented in our code? Okay, so let's look at that. So I'm going to create a simple loop here. Okay, so inside this loop, I'm going to run it for 10 times, and each time I'm going to print out the decimal and hexadecimal followed by incrementing the value of num. Okay, so let's close this first, and I will run it again, compile and run again. Okay, so what do you see here? You see that interestingly, after 1 to 7, I flip over to become negative 1 to 8, negative 1 to 7, negative 1 to 6, and so on. Okay, in terms of the hexadecimal or the binary equivalent, you see that after 7F, I become 80, 81, 82, 83, and so on. But I have a leading F, okay, in the hexadecimal representation. And why is that so? This is called the padding or the sign extension that automatically happens in the system. Okay, so as mentioned in the class, when I declare a variable such as this character or integer, anything for example, by default it is considered a sign variable, which means that half the range is positive, half the range is negative, and the half is denoted by the most significant bit. So once my most significant bit flips over, that means from 7F, okay, so if I subtract 1, this is your 7F. Okay, so until I hit 7F or 1 to 7, my most significant bit is 0. Subsequently, once I add 1 to it, it becomes 1 to 8. But 1 to 8, when I flip over, when I look at the binary representation, the most significant bit is 1. Okay, so in terms of a character, the 8-bit value, once the most significant bit is 1, it is considered a negative number. Correct? So that is why it is now represented in the 2's complement format, okay, as a negative 1 to 8, negative 1 to 7, and so on. In terms of the hexadecimal, basically what you are getting is the actual representation with the padded ones in front. And why you pad ones in front? Because it is a negative number. You are printing it out, okay, here as a percentage X. In percentage X here, what it will do is it will print out the number using the total number of bits that it's supposed to represent. Okay, so in this case, hexadecimal is represented using 1, 2, 3, 4, 5, 6, 7, 8, 8 times 4, which is 32 bits. Okay, so it's represented as a 32-bit system, 32-bit number. So that is why automatically it pads ones in front of the most significant bit. For zeros, it doesn't need to pad zeros in front. Okay, so it assumes that there is actually zeros in front, but it is not shown. But for ones, it is explicitly shown because in this case, it is representing a negative number. Okay, why is it negative number? Because we have declared it as a character, which means half is positive, half is negative. Now, the same thing, all I'm going to do right now is I'm going to change from character to unsigned character. Okay, so now what am I doing? I'm telling the computer or this program that this character variable is now going to be treated as unsigned. That means from 0 all the way to all ones, it is going to be only treated as a positive number. As a positive number. There is no negative representation. Now, the same code, only from character, I now say unsigned character. I'm going to compile and run. Now, let's see what happens. What do you observe? You observe that now from 127, which is 7F, it goes to 128, 129, 130, and so on. Okay? So, there is a change from here onwards. Why? Basically, because that right now, since I've declared it as an unsigned variable, which means all my numbers are represented as positive numbers. Okay, so from 7F, I become 80, 80, 81, 82. It is the same binary bit pattern as before, except that since now this is considered as a positive number, I do not need to do any form of sign extension in front. Okay, in terms of a 32-bit hexadecimal number representation. Okay, that's why I said in hexadecimal format percentage X, it will print out the full 32-bit representation. So in the 32-bit, if it's a negative number, that means the most significant bit is 1, it will do automatic sign extension. In this case, this is considered as a positive number, so I will not do any form of sign extension. Okay, so that is why it is carrying on to print as 80 or 81, 82, and it never pad any F in front. Okay, similarly for the decimal, from 127, even though I flip to the most significant becoming 1, it is still considered as 128. Okay, as you can see over here. Okay, if I now negate this, okay, if I put a negate here 128, you will see that the 80 still is the same, except that now I have padded all the ones in front. Okay, so the difference is what? The difference is whether you are declaring it as a positive number or negative number. Okay, and the program will also interpret it differently. Okay, so this is important. Why? Because you need to know whether you are going to make use of the full range of those of the 8-bit or 32-bit number, or you only going to use half the range for positive, half the range for negative. Okay, so in some cases you want all positive numbers. In some cases you will want to have both plus and minus numbers. Okay, so this gives you an idea, okay, of how numbers are represented, okay, in the system when you declare it as a normal signed variable by default, or if you put in the unsigned keyword before the variable. Okay, so it will differ in the way in which the numbers are treated. Okay, and when you do this addition or any form of manipulation where the most significant bit changes over. Okay, so again, you should try this, okay, and see for yourself how the numbers and the representation changes when you declare it as a normal variable or an unsigned variable. Thank you.